Yeah, so thanks for having me. We're going to hand out a few little pieces of paper. There's 75 of them, so I don't know if there's one for everybody, but it's a piece I'm going to talk about at the end. Is an app we're using called Untitled Chapter that dovetails into Revit, and you can actually export it to a viewer on your phone and look at things in sort of virtual reality on your phone. So it's a fun little piece that we've started to use with our clients. So we'll talk about it a little bit at the end, but if you want to like download the app and follow the instructions on the paper, then you can kind of look at it yourself on your phone as well. So today I'm going to sort of talk a little bit of sort of case studies, lessons learned that because we've been using Revit since 2008, so we've been using it for, I guess that's 10 years. Well, so we've learned a lot of things over the years, things we would do differently, things we didn't do very well, honestly. So I'll try and talk about some of the foibles of our experience, as well as things we think we did well, and sort of where we're going with a couple of pieces. I'm going to end off sort of talking about visualization from a client perspective, as well as information and how we can make things more sort of data rich within the BIM environment. So this first project that we did, we went down the BIM or Revit road on, in this case, was Queen Elizabeth Pool in Edmonton. We thought it was a really good project to be the first BIM project our company had ever undertook, because it's a seasonal use building, really simple wall systems, structures very straightforward. It was a good place to get into the Revit world. So this was 2008. Myself and one other architect in our office were the people that said, yes, we want to use Revit. We're going to go forward with this. This was our first project. So so you can see the Revit was basically done structural, architectural only. You can see the Revit model, you can see the beams, you can see all the pieces, really, really straightforward. But all the complicated stuff from mechanical and electrical, a lot of it's underground. So none of that was modeled. Everything was done two-dimensionally, because they, at that point, 2008, were not ready to use Revit. They were like so scared of Revit at that point, and some are still maybe today, but the consultants we had in this job were like, there's no way we're using Revit on this job. So this is what we had. This is all the pool piping and different things connecting to the pool back to the mechanical room, which honestly, all the problems we had in the job were generally that stuff. This is nothing against a mechanical engineer. Like, this is not about that. It's just about everything that wasn't modeled became parts where we had coordination issues. Heights with pipes crossing over one another that didn't match up where they should have been, and those kind of things. Where if we'd have modeled them at the time, we probably could have got all that stuff figured out before it went into the construction manager's hands. So that was probably the big lesson learned on this job for us. You know, that whole 2D and 3D coordination takes a lot of effort. 3D coordination takes a lot of effort as well, but 2D coordination into that whole environment is even worse. So how do we find ways to leverage three-dimensional work better so we can coordinate the project better? All building consultants using Revit. And one of the questions we still ask today, are we better off doing our architectural site plans in Revit, not doing them on AutoCAD? Because again, that translation of linking things back and forth between 3D and 2D from a site perspective is always problematic. So this was the first project we started with asking that question. So the second project, so following the Queenie Pool, was the Meadows Community Recreation Center and Library in Edmonton as well. And this one, again, probably I think this is our third kind of major Revit project. Also a massive step up in scale, $95 million. Complicated program, all those kind of things. We thought, wow, we did it on these little jobs that were like $5 million. Why can't we do it on a $95 million job? No big deal. But again, there was a lot of lessons learned trying to do that, again, with consultants and collaborators who maybe weren't as robust going down the BIM road as we maybe all thought we were. So here's our team, like the Children's Hospital, variety of consultants located all over the place, trying to work efficiently through the BIM framework. So yeah, a lot of them on the prairies, but then we had our coatics consultant from Wisconsin. We had a couple consultants from Toronto. So yeah, trying to make everybody work together to create something efficient was definitely a lot of work. So one of the things that we did at the beginning, and this was our first foray into this idea of how do we work together in an integrated model setting with other linked models in it. So Group2, at the time we had structural, so our architectural and structural model for a portion of the building, as well as the entire mechanical electrical was one model. this was a lesson learned. I would never do that again. But we did it at the time because we thought it was the right thing to do, and it's not the right thing to do. But we learned a massive lesson on trying to do it and how difficult it was. Because as a firm, we had to get a whole bunch of extra hardware that we had to buy to actually be able to make that even happen. So that when Williams Engineering decided to sync their model at 3 o'clock, it didn't crash the whole model so that architectural and structural was like locked out at that point. So that was a massive lesson learned for us. So we typically don't do integrated models anymore. So then we also had individual models from Perkinsville, Hopper, Yawley's, and WTI that we had linked into that model. So, and the scope was basically broken down like this. So there was a expansion joint in the building, which is where the vertical blue line is. That was sort of the Group 2 architectural structural portion. And then Perkinsville, Hull, Yawley's was on the sort of the right-hand side of that line. And then Williams Engineering was throughout. So what we thought this route of going down an integrated model for a large portion would make it simpler. It didn't. It made it more complex when we got down half. Talking about color and different things like that earlier. Yeah, one of the things we really did on this job was we using Navisworks to create visualization for the design teams to try and look at those clash detections, the different scopes, to really try and help us all understand where those pieces are. We definitely use color a lot to try and make those things work. So you can see blue are all piping, green is HVAC, those kind of things. So we can really see those components and where they were when you built. The other thing that we did, again, very high level at this point from a clash detection perspective, because this was 2010, 2011-ish, is everything was really done in a PDF. So this is taken as a snapshot from the model. We would mark things up, so how we can actually do coordination for different pieces. And we still do this today, but I think there are way more robust ways that we can do this on today's basis, because you can really look at it and you can start to figure out where the pieces are, but it relies upon one person or multiple people looking at a model, marking it up, sending it across. We can do this much, much more directly now than we used to, which I think is a great thing. So lessons learned, the integrated model piece is like, never do that again. BIM execution plan. Our BIM execution plan was okay. I think it could have been way more robust. I think it would have been better to get everybody on the same page at the beginning of the job. And I think the discussion earlier about flexibility, be flexible on some things, I think, again, was also a thing that we maybe weren't so good at that point. We thought it had to be done this way. And I think if we had to learn, listen to our teams and probably listen to ourselves, we could have made that better just by being more flexible. Again, as I talked about clash detection and the discussion earlier about the Children's Hospital, the contractor using the model. This was an interesting one because the contract for this job for us as the design team was to produce 2D documents. The model was not part of the contract. We provided the model to the contractor to help them along from a visualization perspective. But what happened was it ended up asking more questions about things in the model. And we would have to tell them, the model's not the contract. The documents are the contract. You can't say to us, well, I can't find this in the model. That's not the point. What's on the documents? And so there ended up being this kind of level of distrust, in a sense, between the model and the documents because we gave them the model to use. Even though we were very clear at the beginning, it's just for visualization, they tried to use it as well, I can't understand what's going on in this room. I'm going to go look at the model. And if I can't figure it out, then I'm going to blame the model or blame the document. So it became this kind of like weird circle of disinformation and confusion because we gave them the model. In a sense, I feel like we shouldn't have given them the model. I think we would have been better off to not do that at the time. Again, this was 2010, 2011. So today, I think we'd have a bit of a different way to do this. But at that time, it was like, I again, lesson learned. I was like, I'm not so sure we should do this. So anyway. So next one, so St. Joseph's High School, St. Gregory High School. So this is a sort of joint two schools project. Where we leverage BIM very, very heavily, so I'll talk about that. This is an IPD project, so Integrated Project Delivery. We had 14 partners, so 14 signatories to the contract. Design team, contractor, owner, mechanical trade, electrical trade, structural steel, glazing, etc., all signed one contract to build these buildings, through this contractual model. And the only way we could really do this was through the use of BIM. Trying to do it through the use of AutoCAD, paper drawings, all that kind of stuff, I think we probably would have completely failed. But what we were able to do, budget of 51.1 million, came in at 47.8 through the whole IPD process and kind of lean construction techniques. So why use BIM? Well, obviously with the contractual model, it made lots of sense because we were able to put not only the design team in the model, but subtrades, general contractor, everybody can kind of work through the model very, very early on in the process. It's not just handing it over at a certain point. It's actually very, very collaborative where you can get your various trades into the model, working it out. So the idea of building it twice, building it virtually once, and then building it in the field a second time was definitely the only way we could have done that was through the use of BIM. So here's sort of a list of tools that we used. I would say there was a couple of pieces here that really were new, I think, for us as far as using them on-site integration of the BIM environment. On-site computing stations and tablets for all of the trades, and being able to look at the model through the process while you're standing on site was very new for a lot of the trades we had in this job, but they were all very, very excited about it and really bought into that process. The use of field wire, so for doing deficiency reviews and things like that, that's the tablet on the right. Being able to go through and mark things down on a floor plan when you're doing deficiency reviews and those sort of processes. Again, trying to make things done digitally versus doing them like I'm writing things down on a piece of paper. Way, way better, way, way more efficient. We've since implemented this on a couple of other projects. So they set up sort of these portable computer stations all throughout the job site so that the trades can go back and look at the model, because there is no paper drawings in this job. The whole thing was done using the model. We didn't issue a single piece of paper, even with the city of Red Deer. For our code, we didn't issue drawings. We actually got them to the site and we went through the model with them and were able to get them to sign off on it without issuing them any real drawings. So that whole process was really, again, completely foreign. I think it's the first job I know that we've ever done like that. But again, the buy-in from the trades on that whole process was the only way we could get that done, and doing it through the BIM environment. So through the process, I mean, the big piece that we had to all figure out is, what do we need to model, and what information do the trades need from us? So that was a long discussion, because we're all so used to, for example, millwork. I got to draw millwork, I got to model millwork, I got to put drawings together that have way more detail than we actually need, because we have to all cover our asses, because that's the way the contract model works out. In this case, we didn't do any of that. Almost like the pieces were really done through a model. We had a kind of detailed book of kind of details that we gave to the trades, and then the specs, and that was it. So we didn't really have all these other additional things that we seem to always have to do in a set of design, bid, build world to protect ourselves when it comes to contracts and getting sued. So this is the way we did it, and it was fabulous. So hand off the contractors again. Yeah, we handed the model off, and everybody was working in the model collaboratively. And there was lots of back and forth through the process. We would update the model as things changed on site, because actually, I'll go to level development first. So lots of conversations about LOD earlier today. I think, in my mind, what LOD really means is we need to agree on what that means at the beginning. And then people can then go from there. Because on this project, I don't think we had anything that was over LOD 300. And I think most everything was between LOD 200 and LOD most. Because there was no need to go to that level of detail. Because again, we talked to the contractor. What do you actually need from us to do this? Oh, well, we're going to produce our own stuff anyway. So we just need this to tell us in elevation what it's going to look like. Oh, perfect. That's great. So we can give you that. So have that discussion right at the beginning of the job to make sure that everybody's doing what they need to do and being efficient. Clash detection, we've talked a lot about clash detection. We did a lot of that on this job. The great thing about doing it here, though, was we had the mechanical, electrical trades in the model before the building was under construction. So we can all talk about those pieces, not just mechanical engineers, architects, electrical engineers, but all the trades in there as well, to work through that whole process again very collaboratively to make sure we got to the right solution. So here's my as-built precision layout. So we had one guy who was basically on site every day, and he was doing surveying the building as it was going up. And we would literally update the model based upon the points that he gave as the building was changing and the building was moving. So that the model, when it was all said and done, the as-built model was as-built of what was actually built, not just a kind of quasi-representation of what was actually built. So that whole process, I think, was really amazing. And it's not something we really thought about honestly going into the job, but we found through the process that whole idea of an accurate as-built, again, back to the discussion earlier about owner's requirements, that whole piece was such a big deal. So the owner gets an as-built when it's all said and done. The whole idea of source of truth. So one of the things within the model, you still have other models that different trades are doing. For example, our structural steel trade using Tekla to model their pieces. So at one point we had to overlay the Revit model and the Tekla models to see how things were working out. And we found that there were things that were bang on the right-hand side, things on the left-hand side where those pieces weren't aligning. But again, the question was asked at one point, well, which is the source of truth? What is the thing that how it actually ended up getting built when it was all said and done? So we had to go back and do a bit of coordination with that trade to make sure which one is the source of truth. Was it actually built like the one on the right, or was it built like the one on the left? So that whole idea of the as-built model constantly being up to date was really critical. So lessons learned on this job, really, the idea of efficiency because of the VDC, the virtual design and construction process. So the as-built information is like extremely accurate. That was a big one. The idea during the design process, the co-location of mechanical, electrical, architectural, everybody, and then the trades all in a room working together in the BIM environment. Amazing to get the feedback of all the trades through the design process and say, why would you guys do it that way? Why don't we do it this way? Because you know what? That's more efficient for us from an installation perspective or whatever the case may be. And those ideas come up all the time. So they can really impact the design in a positive manner. And then, construction site to production site. So being able to be able to use the ideas that come out of the BIM environment to create efficiencies through prefabrication, different things like that, and then fundamentally cost savings. So we did a bit of an analysis with the general contractor, which is Shandos Construction, and the owner to figure out how much do we think we saved on all of this stuff by using BIM as robustly as we did. And we figured we saved over $1 million when it was all said and done. From the client's money to our consulting team time. That's what that $1 million equals to. So it can work very, very robustly if you do it well. Okay, so 2018. So where are we today? So one of the things that we always have trouble with at the beginning of a job, say pre-design, is client comes to you and says, I want you to produce a functional program of my building and some room data sheets before you go into schematic design. So how are those things done? Well, those things are typically done in Word or in Excel, but they really don't have a lot of relationship with Revit when it's all said and done. That building information model, building information piece, they're really outside of that. So we've been struggling for many years on how we can leverage the pre-design stage into the sort of schematic design stage and put the two of them together better through different methods, so that information that's captured in that pre-design stage can really flow directly in, versus it being this kind of standalone document that hopefully somebody references at some point instead of just being sitting on a shelf or sitting on a drive somewhere. So what we've done, and I'll give a shout out to Dorian from our office who's over there, who did a whole bunch of research on different methods or different types of software that we could use to leverage that information better, and we chose DRofus. And the great thing about DRofus is that we can produce our functional program, we can produce our room data sheets, all these pieces directly in DRofus, and they actually have relationships to Revit when it's all said and done. Information gets pushed back and forth between the different software pieces, so that information really is impacting the building and the project as it moves forward, versus it being, again, this standalone piece. And you can export it out, in Excel and in very, very, very many other ways, so that you can make use of that information. So we're Raphael brought up earlier the Justice Center from Red Deer, one of the projects we're working on right now. So I'll talk a little bit about, we're using DRofus on that project as we speak. So this is a sort of expert of the model and typical things you see within Revit with the properties palette. But there's now a little button in the bottom left-hand corner with DRofus. So you click that, and now you get a DRofus properties palette. So that there's so then the little arrows on the right-hand side, which you can see. Orange tells you how the information is being pushed, which way. So the blue is pushing from Revit into DRofus. Orange is being from DRofus into Revit. So there is a complete connection between these two pieces when it's all said and done. And so you can develop a functional program where you have room lists, you have room areas, all those kind of things very robustly in DRofus, and you can actually physically link that into Revit so it can actually impact what you produce in schematic design. And this is the thing we're always struggling with, how we do this in a robust kind of way. So here's what from a room data sheet perspective, or the sort of information you can catalog within that. So this is again using DRofus, all the different pieces you want to know in a room. What's the wall base? What's the ceiling made of? All that kind of stuff. You put that information in again, and now it's linking back and forth between Revit and DRofus. And we were talking about source of truth for this whole thing, because the great thing about this is you can that movement of information back and forth is good, but you got to be careful that someone doesn't push information one way without knowing what's happening on the other side. Right? So the great thing about DRofus, they create logs to tell you when that information gets pushed, so you can tell if someone did something they shouldn't have been. You can actually tell through those logs. So that whole idea, again, we've started just started using this on 2 projects. The Justice Center is one, and a school is another, and we see the massive potential of it for all of these components, because room data sheets, for example, are a really easy way for a user at the very beginning of a job to understand what goes in their building before you have to draw. You tell them what goes inside a classroom, how many chairs do you need, what's on the walls, what's the floor made of, all that stuff. It's very easy for them to understand this. So if you can get those requirements early, you can link them in through DRofus. Now they can impact what goes into your schematic design model. And you can actually check, DRofus will actually do you can check areas between things. So for example, you tell it, I want a classroom that's 75 square meters. That's what's in the functional program. You put a classroom in that's 70 square meters, it'll tell you that it's not right directly in Revit. It'll show you can do it through a color, it can do DRofus, it can show you the errors that you've made on all those pieces to make sure that they're tied directly together so that you're not hopefully overriding information. So hopefully I'm just going to check and see if this guy will work. I'm hoping we're connected to the internet, but we'll see. Oh, I'm just going to see if this works out. Yeah, let's see if it's working. So visualization. So another piece that we're exploring more and more, which is, again, I think I try to disassociate visualization from modeling, because modeling is one thing, but actually giving it to a client to help them understand what they're getting is another thing. And so we've started to use a couple different pieces of software to help our clients understand what they're getting. Because most clients honestly can't read a 2D drawing. They can't read a floor plan. 75% of the people out there don't even know what a floor plan is. So this is the way that we can actually help them understand what they're doing. So this is an export from Enscape, real-time rendering plugin for Revit. You can make changes directly and it will update instantaneously. You can change color, materials super fast. I can send a QR code to a client via email. They can scan it on their phone, and they can do. This is just 3D visualization. This is our office. We're doing a kind of an expansion of our office, and so it's a really easy way for a client to look at it and go, oh, and they can actually just take and go, I don't really like that one wall. It's the wrong color, it's the wrong height, or whatever the case may be. A really quick, simple, easy way for them to visualize what they're going to get when it's all said and done. Because that's one of the things also we all struggle with. It's all really great to build a model, but hopefully the client understands what they're getting when it's all said and done. Because I hate when a client comes into a room, building's under construction, or it's supposed to be done, and says, I didn't know that. That's the part of the process we never really hear. So we started using Enscape quite a bit for that. It's a really, really great, simple piece of software. It's an add-on to Revit, fairly inexpensive. So it also can use it. It can use it through the cardboard view as well for using your phone. So there's a lot of applicability with today's technology. And the last one is, hopefully everyone got that that little piece of paper with Augmented Texture. So Augmented Texture is an app. Again, I'll plug in with Revit as well. There's an app you've got. So basically, you take your camera, you take a photograph of the QR code. It'll download the model simply to your phone, and then when you take the piece of paper that has the floor plan on it, and you look through your phone or a tablet or whatever the case may be at the floor plan, it'll actually bring the building up three-dimensionally, and you can move around and look at the building. So I'm going to show you a little video of that. Feel free to play around with it yourself. So this is a video that I did. It's purely through a capture from my phone, so it's a bit herky-jerky, but you'll be able to get a sense of how it actually works. So this is the piece of paper basically sitting on my desk. This is our new school in Boston. We have just started construction. No people. If they're in the model, they can be, yes. Yeah. 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 So, I think I just put enough time so far, so that's good. Excellent, thank you. Okay, perfect. Well, this is my last slide. So where are we going? I mean, I think one of the things that we're seeing more and more, obviously, is cloud-based technologies, be it through Augmented Texture or BIM 360, lots of different things. I think that's a big piece of where we're using that now on a very, very good way. Construction site use of building information modeling, Revit, Navisworks, all those kind of pieces. I think again, that's where we see the industry going. Right now, it's hard to do. I think in many ways on certain contract types, it's not so simple. But I know that's where we're going. Our contractors are getting way more advanced in these things. I know working with PCL. I know there's some representatives here. We've worked with Stuart Olson in Alberta, some other ones. They're all very technologically savvy on these things. So that's really coming. The other piece is being able to use technology versus walking around a job site with a set of drawings. Using technology way more to do efficiency reviews and site reviews and all those kind of things. We're trying to do much more of that. And then lastly, this is a picture of throwing virtual reality glasses on. Trying to use VR to help with visualization, as was noted earlier, not just for a client, but also on the job site. That's that next level to getting to that point where as a tradesperson, you can get into the model with that VR headset on the job site. That's where we're going. So I think the use of BIM, use of technology, all of those pieces, I think are really going to impact the construction world. I think sometimes we are, as a construction industry, a little bit slow to react to these pieces, but I think I see it's kind of coming more and more, and I hope it'll just snap itself up over the next few years. That's it.